Hey folks, today we're going to be looking at population changes. This requires a little bit of math, so I'm going to talk you through some of the calculations we can do and give you a chance to practice with this as well. Now, when we talk population changes, we're thinking from one generation to the next generation. And there's actually a lot of ways that you can calculate this, so I've boiled it down to just sort of the simplest elements that we can think of. So if you want to figure out how population changes, you need to look at two things basically, births and deaths. And if the number of births and the number of deaths are the same, then you'll have no population change. If the number of births is bigger than the number of deaths, then the population grows. And if births is less than deaths, then you're going to have the population shrinking. So let's look at a few factors that we could use to identify this. And the first is going to be defining this term, which is called survivors. There's a lot of ways to break up when organisms die or how long they survive. You might think about things like infant mortality rate or prenatal mortality rate. But we're just going to strictly look at the most general categories here. So we're going to think of survivors as being those individuals that make it through to the age where they can reproduce on their own. So no further distinctions on this one, just do you survive long enough to reproduce? Doesn't matter when you would have died if you weren't in that survivor category, whether it was before you were actually born or very shortly after you were born, or the day before you would have been old enough to reproduce and did so. Anytime before that, we're considering to be not in this category of survivor. And realistically, from the standpoint of looking at population changes, that's really what we care about. Once you have reproduced and are no longer going to be reproducing, it doesn't actually matter what happens to you after that, because we know that every individual is going to die at some point. The real question is, on the long term, did that individual manage to have offspring? And will those offspring manage to have offspring? So if we think about a population of, let's say, ducks, and let's call it 20 ducks to start out our generation. Out of those 20 ducks, not all of them will make it to adulthood and be able to reproduce. So let's just make up some numbers here. Let's say 5 of them are going to just never hatch. 3, 4, 5. Something goes wrong with the egg, or a predator goes after the egg. Those 5, they don't even get started. And then how about another 3 die? They're young little ducklings. They're pretty helpless, just like babies are. And one more, not quite ready to reproduce duck, gets taken out by a different predator. So we have 9 of them die off out of the 20. So that leaves us with 11 survivors. Now, one thing we might want to do with this is to calculate what's called the survival rate. Survival rate being the total number of survivors divided by the total number of organisms in the generation. And generally we make that a percent. So I'll just add times 100% in there to convert that. So if we did this one, the survival rate for these ducks would be 11 over 20 times 100%. And let's see, 11 over 20, that must be 55%. A 55% survival rate. Okay, so next up we need to look at not deaths but births. So 55% of our ducks survived, and those ducks then reproduce. How many new little ducks are we going to have around? So now we turn our attention to something called the reproduction rate. And this is just the average number of offspring per adult or per parent. Now, the only thing that's a little tricky about this is the per parent thing. Since we have ducks reproducing sexually, there's 2 parents. So let's say that these 2 parents, who are a couple, they have baby ducks. And for this example, let's say these two ducks have 5 ducklings between the two of them. And let's just use that as the average. So an average member of that group that we talked about before, out of the 11 survivors, they couple up, and the typical result is 5 ducklings per coupling. So to calculate reproduction rate, we just do the number of offspring divided by the number of parents. And in this case, that's going to give us 5 divided by 2, which is 2.5. Now, again, this is an average, so we're not saying that the normal family is 2 ducks and then half of a duck extra. We're saying that, hey, there are going to be some that have 2 ducks and some that have 3 ducks, or just that, the number of ducks is not evenly divided, number of offspring ducks is not evenly divided by the number of parents. If we wanted to look at the whole group, we had 11 survivors before, so maybe there instead we would say that those 11 ducks, as a result of their pairing up, maybe they had something like 30 offspring, so just making up a number for how many offspring 11 of those ducks would have. So then we'd do 30 divided by 11, 30 offspring divided by 11 parents. And then we'd calculate that 30 offspring divided by 11 parents is going to give us 2.73. And then that's offspring per parent, if you want to do units on this. And that would be the same up here, offspring per parent. Okay, so we've talked about deaths, we've talked about births, reproduction. The last step is to put these two together, and we look at what's the size of one generation compared to what's the size of the next generation. So the last measurement or ratio that we calculate to make this comparison is called the fitness of the organism, or the fitness of that species, or the version of that species with a certain trait. And this is just a ratio of numbers from one generation to the next. So to calculate that, we need to know how many are in one generation and how many are in the next. Let's say for that last example, we had 20 ducks in the first generation, and in the second generation we end up at 25 ducks. So some of these 20 didn't make it to reproduce, but the ones that did, they reproduced enough that we actually have more ducks in the second generation, more offspring, than we had parents originally, or ducks in the first generation. So to calculate fitness then, we would do the number in the second generation divided by the number in the first generation, which is going to be 25 over 20. So then fitness is going to be equal to 1 and 1/20, so that'd be 1.05. And this one we just leave as a decimal, we don't do a percent for this. 1.05. So that that second generation, shoot, realized I screwed up on the calculation, not 1.05, 1.25. 5/20. It's a quarter. My mistake. So that second generation has 1.25 times as many individuals as the first generation. And then if we had done this over a large number of organisms, we'd be pretty confident in the results, and we'd take a look at data over multiple generations. So then we might be asked to make a prediction, like what's the next generation going to look like? How many are going to be in the next generation? So in order to do that one, 25 is our current generation. The next generation, there we go. How many in the next generation? Well, we'll just take the 25 and multiply that by the fitness. Multiplying by fitness is always going to give you the number we expect for the next generation. So that'd be 1.25. which is going to be 31.25 as our estimate. Now, obviously, we're not going to end up with a quarter of a duck in the next generation. That's okay. This is our estimate from a mathematical model. We recognize that the mathematical model isn't going to give us a perfect answer. And here's one example of why. It gives us a fraction of a duck for the next generation. Not real realistic. But we expect then it's probably going to be 31 ducks, maybe 32 ducks, or it could be slightly off in either direction. Things happen, and maybe it doesn't follow the pattern exactly, but that's a pretty good estimate anyway for how many would be in the next population, all things being consistent. So now that we've been through a couple examples of calculating these things individually, next step is to try some practice on these on your own. So, have at it. Here's a problem that involves every one of those calculations and should give you ample practice to figure out how all these calculations work. Next step on this is going to be how do we extrapolate, how do we figure out over larger numbers of generations. And that's where doing all the calculations by hand is going to be a pain. Spreadsheets are going to be useful. So we'll figure out how to implement those, but first we just need to get a little practice with doing the calculations in the first place. So get some practice with these. You'll want to pause the video now because it's going to end, and that way you can see the question here, and answer keys will be available or it'll be discussed in class. Get to work.